Hello guys, welcome back to Zone African Motives, still on engineering science and two. In this platform, we shall be focusing on dynamics, which is a revision from the question paper, which was written in November 2022. So we're not going to waste much time. We shall quickly rush through the questions that we are given. The first question on 1.1, we are given to convert. So take note that is a conversion which is supposed to take place to convert 0.02 meters to centimeters. Okay, so how can we convert meters to centimeters? We are going to take from our conversion. We know that in 1 meter, we have got 100 centimeters. All right. So if in 1 meter, we've got 100 centimeters, that means to convert 0.02, we are going to simply multiply by 100, which is 0.02 multiply to 100. Okay, so from your calculator, this is going to give us a 2. That's 2 centimeters. Remember, we are multiplying by 100 centimeters. So our answer is going to be 0.2. Okay, that's 1, 2, 0.2. You see this issue of not using a calculator, it actually affects. All right, so that's a 0.2 there. All right, so in this case, please make sure that you use your calculator properly, guys. You're going to obtain 0.2. All right, on 1.2, we are given that a man runs for 6 kilometers directly east until he gets a T junction, okay, where he turns around, runs 8 kilometers directly west. Determine the following, okay, the total displacement of the man. All right, so this is what is happening here, guys. This is 1.2. So we are given that there is a man who is running towards to the east, okay? So that's to the east in this case. We know that from our north, from our north pole, that's north, south, east, and what? And west. And whenever you are going to the east, you are on the positive region, okay? To the west, you are in the negative region. So we are given that a man is running towards the east for 8 kilometers, all right? For 6 kilometers, okay? Direct to the east, that's 6 kilometers. So we are going to have the man running to the east, all right? For 6 kilometers, okay? That's a positive. So this is positive 6 kilometers, okay? Then at this point is going to meet a T junction, then he runs back direct again in the west for 8 kilometers, okay? So he's now going back in the west direction for 8 kilometers. That is in the same line or same concept that we have, but 8 is actually bigger than this 6. So we shall have our 8 going to the west like this, all right? So the man is starting from this point going to the west. And whenever you are going to the west, that's a negative. So this can be represented by a negative 8. But just know that you are going to the west, so it's a negative in actual sense. But we know that it simply means it's 8 kilometers to the west. But know that that one carries a negative, and this is 6 kilometers to the east. All right. So the question is to calculate the total displacement in this case. So remember that the displacement is the resultant that we are going to obtain from the starting point to the ending point. And in this case, if you are to check, this displacement is going to be the difference between these two, because the main to go this side, then again this side. So the resultant is the difference between the two, which is this one. So it's a negative 8 and a positive 6, which is going to be negative 8 plus 6. That's a negative 2. So the negative is showing that you are going to the west. So the final answer in this case is just going to be 2 kilometers to the west. Sorry for that. Okay, sorry guys. That will be 2 kilometers to the west. All right, so we shall have in that manner. So like I said, the negative is simply indicating the direction, but the answer, you write it in as a positive and indicating the direction now, which is the west, to represent the direction. Okay, so that is displacement. Then take note now On 1.22, we are now given to find the average speed. Remember that speed is taken from the distance, not from displacement. If it was velocity, then you are going to use displacement. But in this case, it's average speed, which means you must work with distance. So don't be confused here. To continue with the displacement, no, you are supposed to calculate the distance first. Okay, if of the men, if it takes 47 minutes to complete the exercise, give the answer in kilometers per hour, but take note your time is minutes. So you're supposed to convert this to hours because your answer is needed in kilometers per hour. Okay, so let's start by the distance first because we must have the total distance which was traveled in this case. All right, so this is 1.22. So to find the total distance, we are referring to the total of, remember, if you are given something like this in this nature, you add A, B, and C to find the total distance. But if it is displacement, you calculate from this point to this point, from the starting to the end. So when we are referring to the distance, we are going to calculate every movement which was taken by the man. He took 6 kilometers going to the east. He took 80 kilometers going to the west. So you shall combine the two, the 6 kilometers and the 8 kilometers, which means the men took 14 kilometers all in all walking. All right. So we have the distance and we are given the time, but this time is in minutes. If we are to check here, we are given that our time is 47 minutes. So we have to convert this to hours. All right, remember guys, to convert to hours, you simply have to divide because we know that in an hour, we've got 60 minutes. So if we've got 60 minutes, to convert 47 minutes, in this case, to hours, we divide, that's 47 over 60 times 1 hour. So it is going to be 47 over 60. That's our time in hours. So we have the distance, we have the time. What about the average speed now? Because the person is asking us to calculate the average speed. We know that speed is equivalent to the distance over the time. All right. So that's your distance in kilometers of 14 over the time in hours. And we determined our time in hours, which is 47 over 60. So it's 47 over 60, just open bracket for that 47 over 60 so that you can obtain the correct answer there. So it's 14 divided by, you open the bracket, 47 over 60 like that. You're going to obtain your average speed in this case, which is going to be something like 17,872. If you run properly, that's 872 kilometers per hour. All right. Because you were dividing here, take note, you were dividing distance in kilometers by the time in hours. So that's why you are going to have kilometers per hour. All right, so that's 1.22. That was it for question 1.2. Okay, 1.3, we are now given that a motor car travels at a constant velocity of 10 meters per second for 15 seconds and then accelerates at 0.5 meters per square second for 10 seconds. Calculate the final velocity of the motor car. All right. So in this case, guys, we are given a condition whereby we can list the information that we have. We can just list down the information here. A car, that is a motor car, travels at a constant velocity. That is your initial velocity. So we are given the initial velocity, which is at 10 meters per second. Okay, that was 10. Okay, if I'm not, let's check. That was 10. All right. For 15 seconds, that is the time. So a given time in seconds, which is the time in seconds, that is 15 seconds in this case. All right. Then from this information, we are given that and then accelerates for 10 seconds, okay? It then accelerates at this velocity for 10 seconds, okay? Take note that here we are given that previously a motor car travels at a constant velocity. That's a constant velocity, okay? For this time that you're given. So we can find the acceleration for this part. And then we are given that it accelerates at 0.5 meters per square second for 10 seconds. All right. So this is another information that we are given. Okay, that's another information. So we can say this is the first phase of our information, then the second phase of the information where we've got an acceleration of 0.5 meters per square second, and the time in this phase is at 10 seconds. All right. So there are actually two options that we can use to calculate this velocity that we are referring to. All right. We have got to, here we can actually work out with a diagram, or we can work out this information as it is. Okay. But one thing that I need you to know or to understand is that let's just take a closer look. I'm just showing you a sketch. I'm not drawing for this. I'm just showing you how a sketch was supposed to look like. This part here, we are given that there is an initial velocity of 10 meters per second, all right, which is where the object, the vehicle, is traveling at a constant, okay, velocity of for 15 seconds. So in this case, we are referred to the final velocity. It's not like it was, because we can't say it's traveling at a, it was supposed to be constant acceleration. It was supposed to be an acceleration, okay? So in this case, we are given it as a final velocity for the first phase, okay? That is constant throughout, it's maintaining this speed. So it's supposed to be like this, okay? Something of this nature. It was supposed to be like this. So you're going to see that when it covers a distance of, the time of 15 seconds, that's after now here at this point, where we are now starting to accelerate for these 10 seconds. So it's now a shift now, which is an acceleration now of 0.5 for 15 seconds. So what I want you to see is that the constant, the velocity that we are given, which is constant of 10 meters per second, this one at this point, is the initial, and also it is the final velocity, because we are given it's a constant. All right. So for the first phase, this velocity, which we are referring as the initial, is also the final velocity. We are still having the same velocity, which means there is no acceleration. Acceleration is at 0. All right. But here I'm not focusing about the acceleration. I want you to understand this about this velocity. So which means it is going to be the same velocity for this phase from this point. Let's say this is A and B. From point A here, we shall have our initial velocity now, which is that final velocity that we had in the first phase of 10 meters per second. So that is going to be the initial velocity for the second phase, when there is now an acceleration of 0.5 meters per square second. So on this phase, what is the corresponding velocity now, which is the final velocity? That is the one that we are supposed to calculate now. All right. So here from this information, what was important was this velocity, because it's constant. That is going to be the initial velocity also on the second phase. That was the most important part in this question. Okay, anyways, having this, we know that from our laws of motion, we can say that velocity, which is final velocity, is equal to u plus at. All right, which is velocity being final velocity is the initial velocity of 10 plus the acceleration, which is 0.5 times the time, which is 10 seconds. All right, so this is going to be 10 plus 0.5 times 10, which is 5. If you add, this is going to be 15 meters per second. So that is going to be the final velocity, which means that is the corresponding value at this point. It corresponds at 15. All right. So that was it, guys, for the final velocity. I hope we understand what was happening here. Then on 1.32 is now make a neat labeled sketch of the velocity time graph for this motion. Okay, so that was the sketch that I was just trying to show you on this part. But let's just have this drawn properly. Okay, so let's just have our sketch here drawn properly. So you can just sketch out this. This is 1.32. All right. So in this case, we can even, okay, let's just use a ruler, but actually I wanted to just sketch that as it is. Okay, anyways, let me just insert a ruler just in case so that we can have a neat sketch. All right, so we shall have our time axis, all right? So this is our time axis versus the velocity axis. Remember, this is velocity and time, all right? Velocity time graph, okay? That's a velocity time graph. So we shall have our velocity here, this point like this. All right. So from this information that we have, we know that we shall have our time. All right. So this is the axis for time in seconds, and this is the axis for velocity in meters per second. So take note, we are given that this was the first part. I told you that this was the initial velocity of 10. So it was maintaining a velocity here at 10 meters per second up to 15 seconds. So we shall just have it as a sketch like this one. For 10 seconds, we maintain this velocity. All right. So we are going to maintain this velocity for 15 seconds. I mean, the velocity is going to be maintained for 15 seconds. So that means at this point, we can simply say this is our 15. Then the second phase, that is where there is an acceleration. So it's now going up. That's an acceleration. So you can just indicate acceleration like this to a certain velocity, which is the final velocity that we talked about, where we said our final velocity is at 15. So we can indicate that final velocity at 15. So at this point here, it corresponds direct with 15. At this point, it corresponds direct to 15, all right? And at this time, it corresponds after the 10 seconds, okay? We are given that after 10 seconds, so we want to know what is going to be the total time, but that was going to be your sketch, something like this. All right, so that's what we had, a constant velocity for 15 seconds, then an acceleration of 0.5 meters per square second for 10 seconds. So it's going to be 15 plus 10 because we are already at 15. Then we add 10 seconds, which is going to be at 25 at this point. And this is the final velocity, which corresponds with the 15. So this is going to correspond with 15 meters per second. Okay, so that was the sketch that we're supposed to have. And definitely at this point, you start at 0 in terms of time, at 0 in terms of what? In terms of the velocity. All right, so that was question 1.32. Then let's check the other part. On 1.4, we are now given determine from the graph, which means it's a continuation. Take note, guys, from the graph that we had on question 1.32, which is a continuation from that graph. Calculate 1.41, the total displacement. So 3 marks for that. So we know that the total displacement is simply the area. So take note, this one is a continuation from the graph. So we know that the total displacement is equivalent to the area. So this is question 1.41. So we can have total displacement. That's total displacement in this case, which is equivalent to the total area. So we can say we've got shape A and shape B. So shape A is a rectangle. So we can work with a rectangle, which is length times width, okay? Plus, take note on B, it's either you can work with the whole shape as it is as a trapezium. This is a trapezium, guys, where these two sides are parallel to each other. And we've got the perpendicular height from this point to this point, okay? Or you can divide this to be a rectangle and a triangle. By this, you can divide to say you are working with the whole of this shape as a rectangle, then you use the triangle on top, okay? So you choose which one is best for you. So in this case, I'm just going to show you, if you worked with a trapezium, therefore your area of a trapezium is half sum of the parallel sides times the perpendicular height, okay? If you wanted to work with a rectangle from this point up to this point, the whole of this rectangle, therefore it was going to be length times width, okay, plus the part of a triangle, which is half base times perpendicular. You're going to obtain the same answer. All right, so I'm going to use the trapezium concept. Length times width, here I'm referring to A from 0 to 15. That is from this point to this point. This is 15. From this point to this point, that is 10. So it's 10 times 15, or 15 times 10. All right. Plus, for the trapezium, we are going to have sum of the parallel sides. So remember, I indicated that the sides which are parallel is this side here and this side here. So the length is from this point to this point, which is 10. And from this point up to this point, which is the whole of this line, that is 15. So you add the sides which are parallel, that's 10 plus 15 times the perpendicular height now, which is the one that is at 90 degrees. So that is the difference between the 15 and the 25. Remember, this is 15, this is 25. So 25 minus 15 is 10. So there's a difference of 10 here. So you multiply 2 to 10. So that was going to be the total displacement, which is the area. So you can choose to calculate this area in so many ways. 15 times 10, that is 150. Plus, we simplify this side. This is same as half of 10 here, which is 5. So you add 10 plus 5 here, which is 25. Then 25 times 5, which is going to be 125. So you put 125. If we add, that is going to be 275 meters. Okay, so that is the total displacement that we had in this case. All right, on 1.42, we are now given to calculate the average velocity of the car. Remember, displacement can give us average velocity. Okay, so average velocity is a continuation from the displacement. Take note, this was for the time in 25 seconds, and we know that the average velocity is simply displacement over the time. All right, so we shall have, that's 1.42. So our average velocity, velocity in this case is going to be the total displacement over the total time, where we've got a total displacement of 275 meters over the total time. From the diagram, our total time was 25 seconds. So take note, this time is in seconds and our displacement is in meters. All right, so this is 25 seconds here. So our answer is going to be meters per second. All right. So if we are to calculate our average velocity, if we divide 275 divided by 25, we are going to obtain 11. So that's 11 meters per second. All right. So that was actually what we had, guys, on dynamics from November 2022 question paper. We can see that it's very, very important, guys, to revise as much question papers as possible before exams. And this was actually out of 15, total of 15 marks from this person. So please do revise as much questions as possible, and don't forget to invite others to Maison African Motives so that we can learn as a family as we are revising for the exams which are ahead of time. That's it, guys, from Maison African Motives. Till we meet again.